Anime music, thank you. It's Imo. So how's it going? Things have been going well, Ankit. I've been working on I took a break for a week to work on like the conceptual design of my compiler. So basically, what happened is after a couple of days, so this is 6 days ago, I was working on the compiler and I just started thinking, right, if I'm going to implement all these things, the current compiler is not going to cut it, right? So I spent the past week reading research papers, things like that. I mean, just prodding around what other people do. Anyway, the problem is, in my current compiler design, I can't do specific optimizations that I need. Things like language-specific optimizations. I want to be able to optimize closures, right? Imagine you capture a variable and that variable's value is known at compile time, right? You want to inline that variable inside the closure. That's a language-specific optimization, right? And the thing is, I'm a really fucking stingy person when it comes to compiler intermediate representations. So I go to the parser, I take in the source text, and it gives me this tree representation or whatever, right? I want to do type checking on that. I want to do region checking on that. I want to do language-specific optimizations. I want to do data flow analysis. I want to do conditional constant propagation on it. The thing is that that's simply not possible with an AST, right? So this stream right now is to just to talk about my current just to talk about the way I'm headed with the compiler and actually implement the new stuff in this stream. All right, what's so there's a ping everyone. A lot of people, 30 people online. It's I don't usually see that many people online. Usually when it's late, because I don't see many people in here from what's it called, Australia, where I live. Ankit says, what server is that? It's mine, my server. If you go to my YouTube channel, you can find it. Why is it above the harp server? What's the harp? What's harp? HSFP. Because I don't check it. Well, okay, no, I check everything. Right? I check it. Of course, it's above because it's mine. Sorry. All right. No, it's fine. Isn't it dead? The thing's over. How many people? I got 6 viewers. Wow, jumped. Okay, what's the current? Okay, we're 4 minutes. I spend a minute just doing random stuff before I actually get in. What's it saying? Okay, use Twitch and go on the side. All right. Let's actually no. You need context. This is the most important thing. Context. Okay. This is the last stream. This is stream 9. Hold on, let me move the chat to the side so we can see it. Yo, congrats on the success so far. Keep it up. Thank you. All right, so this is context. So this is a functional programming language compiler 09. Actually, I need to change the current stream because it's still saying major syntax changes. It's supposed to say something else. I don't know how to do it though. You know, who cares? It doesn't matter. Okay, I can change it later. Alright, this is the context. FPLC 09, changing the syntax for the better plus aliasing theory. What I do is I change the syntax, and then at the very end I go over my representation for aliasing. Basically restrict pointers by default and checked regions. Like Rust, it's like Rust's lifetimes, but with regions of memory. Think of it as I'm taking Rust's aliasing model, but I'm really just making it more loose, right? So it's more C-like. System B4 says, I'm trying to get into OS kernel dev. If you have any experience or tips, You know, just how I got into compilers. I used to oh, Ankit says, catch you next time. Bye, Ankit. See ya. Yeah. So for OS and kernel dev, um, oh man, it's been so long. You can go on osdev.org. It better not be right. Okay. Osdev.org is great, but it's quite dated. OS.org is very dated. Oh man, I used to want to create my own operating system. This was a long time ago. I'm gonna be honest. You're in for a lot. You're in for a lot. Especially reading like the UEFI specification and the x86 specification. It's not fun. But my best advice to you is read other people's code, right? Because people put their the thing is with old standards, 40-year-old standards, things like the BIOS standard or like x86. The thing is with 40-year-old standards is that they're 40 years old. They don't change, right? So projects from well, not 40 years old. It's super old. Projects that are made on standards that are decades old. You can just read their code and it's the same stuff, right? So my best advice to you is to go online and just look at other people's code. Look at other people's code, written in C, because it's very easy to just see the flow. It just makes a lot of sense. Also, a good thing is to learn how, I mean, how does a modern kernel work? So there's scheduling, there's memory management. So there's an MMU, it needs to do paging. How do pages work? How does mmap work? How does physical memory work? What's virtual memory? Things like that. You have to have a huge array of knowledge for a kernel development. But the thing, it's hard work. Yeah, there's a reason why I moved away from kernel development and going to compilers. The thing is that I just don't want to read I don't want to read a 1,000-page document about the UEFI specification because it like that's not fun, right? What's Lamine? Is it Lamine? Lamine bootloader. This is great as well. The Lamine bootloader. This is I don't know how to pronounce it, but Limine bootloader. This is what I use for one of my operating systems, one of my old ones that I made. Another good resource. I don't know if you're I don't know like what language you're using. Is it VOS something? Yeah. I used to like where is it? Yeah, just C in assembly, but where's the VOS? No, okay. Well, there is actually my VOS, but where is the language V? I wrote something using Lamine. Come on, where is it? There's Matcha Engine CPU. Man, fuck. Okay, it's language C. It's language C. Hold on, I'll cut this out when I make the yeah. JW says Vinix. Yeah, Vinix is another thing, but here VOS bare bones. So this is me using V with the C's thing and Lamine, the Lamine bootloader just so I can get just some code running. So in V you'd like anyway, short story. There's lots of things online that can help you. Specifically, this is a great bootloader to start with. You can just write the code and interface with it, and it would fill in all the requests, like your request for the clock, your request for the CPUs, your request for the amount of CPUs. That's what a bootloader is for, and Lamine is a pretty great bootloader. I don't think you want to deal with a multi-boot specification. It gets messy. So, Lamine throws you into a 64-bit protected mode. It's good to start. It's good to start off. Yeah, Socrates, the real Socrates says, I've been playing around with interpreter dev lately. Do you think my approach can be just jump into it, where I error correct my way through it? I want to build a Lua interpreter, so like jumping through a parser combinator lib like Python parser, or a more theoretical approach. Okay, so I've looked at the Lua specification. I think I had a conversation on the Discord about someone who was using where is it? Parser combinator. Yeah, this guy's making a programming language and he's using a parser combinator. So I looked at the as far as I can remember from the Lua specification, because I just read things when I get bored. It's a very simple language that can be parsed with little to no ambiguity, except for when it goes line by line and there's like a braced expression at the start of a new line. That's something minor. So do you think my approach can be a just jump into it, where I error correct my way through it, jumping into a parsing combinator library? I think you just you can go with a parser combinator. At the end of the day, if you just want to learn how to do interpretation, you don't have to care about the lexing or the parsing. So if you just want to jump straight into that and learn about interpretation and everything and all these intermediate representations, just use a parser combinator, use a library. I mean, I'm pretty sure there's a library to parse Lua already. Out on the internet, on Python. Someone's already done it. You want to skip straight to that, you can use them. But if I was writing like a Lua interpreter on my own, I'd do my own parser. I wouldn't use a library for things, because I want to insert special logic when I'm parsing things and not do it a certain way. Now, it's good that you bring up Lua, because I tried to make a Lua clone a long time ago. This is a long time ago. Good thing you asked, because right now I'm just going through all my old V projects. Where is it? Vua. Oh man, what a dumb name. Vua. Internals. Yeah, so it's a single parser. Lua, it's like a derivative of Lua. Lua is a language that isn't very ambiguous. It doesn't need to resolve anything. All it is straight in the bytecode. So what you can do is run a single pass compiler. So go to like statement, you parse, right line, next, parse more statements recursively, and all you have to do is just push into a stack of values, and then you can push off the values. So let's say you want to parse the plus operator, parse one side and the other side, you put them on a stack, you pop those two things off the stack, and then you have two values, and you can emit them into the bytecode representation. What I'm explaining right now is very simplified. This is what TCC does in their code generator. That's what I'm doing in this Vua thingy, and that's what I'm going to do in the new compiler of this language. Socrates says, I did not think about skipping certain aspects of it. Yeah, at the end of the day, it's your choice. It's your choice. Yeah, Lua is not an ambiguous language. You do not need to know anything statically. You can just go top to bottom, pass the whole thing into bytecode and run it. Because Lua has this specific table operations, and like you can access the globals and everything. You know, it's a nice project that they did. It's a pretty nice project. I had opcodes and everything, into constant pools, and then in the here there's like encoding and reading, and then disassembly as well, and then execution was all of this. And I think what I also did was parsing parsing what tokens are these? Short circuiting. The short circuit operators are the and and the pipe. Those actually have special control flows. So I do this here. I do conditional jump, and all of these things. Anyway, go parse top to bottom into bytecode, and you don't need to do anything special, because Lua is a very simple language. System B4 says, "Are you going to FOSDEM?" I've heard of FOSDEM. I don't know what it means. I don't know what the acronym means. in Brussels. Free and open source software developers European meeting. I'm in Australia. I don't live in Europe. Not many things go on in Australia. It's actually pretty empty. I'll check Vua out. Thank you. It's such an old code base, but I'll paste it right here for you. All right. Good talk. Okay. Oh, my headphones died. Doesn't matter. I'm not listening to anything. Go to the side. Let me just go. Okay. So going back to where we were before, FPLC 09, changing the syntax for the better. I talk about syntax, and at the very end I talk about aliasing. So these are just some specific aliasing things. I released a short video. You want to watch it, you can watch it. And then after that stream is done, I go to here. So this is stream 9. I did if statement changes and node voiding, change procs. This is just syntax changes. I did the node voiding operator, so that's just something I don't have to handle. I did mutable pointers and void expression. Mutable pointers, mutable L values, lets, special bug fixes. I desugar the pipe operators and the and into specific. You can desugar the or and the and operator, those conditional comparison operators, into ternary operators, like the if this and that and stuff like that. All right, and then I did array patterns, infix fixes and pointer arithmetic, desugaring, yeah. And then just renames and stuff, and then index and slice expressions. Not much. What I did in the language, is just specifically just adding features, really. Just adding features and fleshing it out. Okay, and I say here, fix current bugs, working on it. This is that thing right here. 2, separate desugaring pass after type checking. Okay, that's just another thing. Basic constant propagation in the front end to optimize closures. That's important. You gotta remember that. Closure desugaring into struct plus function pointer pairs. That's another thing. Start lowering from high-level intermediate representation into lowered intermediate representation, and generate C code from LIR. I say maybe we'll take a week to get code gen. Who knows? Okay, a week has passed. I don't have code gen. There's a reason for that, because I say here. Anyway, what happened a couple days ago is that I read a paper on the sea of nodes, the sea of nodes representation. When I click on this window, it's going to be a bright white PDF, so I'm not going to click on it. But I'm going to put this link in the description of the video, and I'm going to put it here. All right, I'm going to put that here. This is a specific IR that works as a complete directed like cyclic graph. It's complex. It is complex. I went crazy about it though. A couple days ago, I was like, okay, this will literally solve all of my problems, because if you read here, this language is functional. It supports closures and partial application. It requires bidirectional type inference, so the type information can flow up and the type information can flow down. Usually when you hear about bidirectional type inference, it's a bunch of PhD people talking about some Haskell stuff. But in reality, I do a very, very simple bidirectional type inference. It's simply just recursing down and passing a up value and then getting the value back. I talked about this a while ago. Okay, and 3. Must allow for language-specific optimizations for closures, partial application, and algebraic data types. So I mean like some types. Okay. Yeah, so language-specific optimizations. So, and I'll get to that after. Yeah, type checking of alias regions preferred in the front end. So, I want to type check regions in my language. So if you watch my last stream, I talked about how every variable has a region in memory, and I want every single argument to a function to have their own region, completely. And I want it to raise errors. So there's going to be no aliasing in the language unless you're being very explicit about it. It'll help for me to explain if I click on my obsidian, but I want to just keep going through this. Okay, so this means we can't go to a lower representation than the parsed source. I want to do type checking. That means I need a tree. I want to do optimisations. That means I need flattened expressions, right? They're mutually exclusive. They're not the same thing, which means I'm in trouble. Yeah, and 2, we must be able to perform optimizations on the front end. That's right. We need to perform optimizations in the front end, because if we go to a lower representation than the parsed source, we lose out on the information of the closure, right? The closure is this abstract thing when we parse it. And when we actually lower into a thing, we lose all that information, and it's essentially set in stone. So what we want to do in the front end is do constant propagation into the closure, and optimize it as much as we can with the closure, and then make it like concrete, right? And then give it a type and everything. Now it'll make more sense when I go on. For those optimizations to work, it must be in a proper form. No abstract syntax trees or trees in general. Okay, so no trees. The current IR doesn't work for optimizations. 4, the intermediate representation must be expression tree based to allow for bidirectional type inference enclosures. Right. Yeah, this makes sense. Like as I explained before. Region trees must work with intermediate representation and raise errors. Okay, so this is what I talked about before. I'm very stingy with intermediate representations. Whatever comes out of the parser, it will be the same thing that you type check and do all of these special things. And I also want to do data flow analysis on that thing, which means I need to stay in that single intermediate representation all the way through, which is kind of hard, which is really hard. Anyway, I go crazy about sea of nodes. In reality, I'm not going to go with sea of nodes. I spent the last couple of days really formulating how I'm going to use sea of nodes, and at the end of the day, I moved to something that was much better, and you'll eventually come to see that. All right. This picture is a picture of a graph. This is the sea of nodes representation. So it goes from the start to the end. Control flow flows from the start to the end, and data flows from here, right? So you probably can't see a single thing. There, yeah, you can see everything now. Okay, this is a function that takes in an extern pointer. So this extern pointer is C semantics or something. Anyway, data flows, this control flow flows here. And since control flow is not diverging anywhere, you can expect all these things with dependencies to execute basically atomically. That's a really nice property of sea of nodes, is that you can set up these dependencies. These dependencies will depend on each other, but if control flow doesn't diverge or go anywhere else, they all execute at the same time. And when I say at the same time, I don't mean literally at the same time. It's just a mental model. It's just a mental model, really. This is flow of information, not flow of control. Flow of control goes from start to end. This is flow of information. So yeah, you're selecting one, and you got these two arrays, you index, and you go to a subregion, that's another subregion, you store to a const, you union to get another subregion, you store into that again, and then you store into this again. It's a nice representation. But that didn't end up working out for me. This umbrella projects. Okay, take a look at this canvas. This is sea of nodes. So I'm currently just formulating. I'm going from left to right, left to right, left to right, left to right. Wow, it's just laggy, so laggy, until I get to something like this, right? F takes in a pointer to an i32 immutable one and returns an i32. And this is a global variable. This pointer to an i32 has no region, has no specific region marker, which means this cannot alias with this. You cannot pass a pointer of this into this while still mutating it here. All right. So you can see F binds to EX, which equals a do block, global equals 30, EX equals 20, return global. Now let me move this in here because my camera is probably blocking it. Yeah, return global, and then main just calls it. Anyway, so it goes to the start. You have a pointer to a global and a pointer to an EX. The pointer to a global is a hidden parameter to the function because you're affecting it in its global state. Anyway, it goes start pointer EX. You're storing a const of 20. Global goes from you're storing a value of 30 into a store. This is an effect that has to be propagated to the return, but this mutated region you're passing into a load, and that load loads a value and you're returning it. Now you can easily tell that there is no control flow here, and these two loads happen simultaneously of each other. There is no dependencies at all. So if I go to the scroll up version, this is the optimized version. What you can do now is remove the load. So if you look at the bottom, this start goes to the end, pointer goes here. You're storing a load, you're storing a value, and that propagates into the load, right? Because the load depends on the store, and then you're just returning it. But what you can do is the load isn't clubbered at all. So what you can do is you can constant propagate all the way up here and just remove the load and replace that with a 30. And you wouldn't be able to do this if you didn't know that these alias at all. So you can see the pointer right to the EX and the pointer right to the global, they happen simultaneously of each other. That is regions. This is a really nice way to explain regions in my programming language. Regions, you know for a fact that they are not going to alias. That means they can happen independently of each other with no dependencies. So you can see, I mean, it makes sense, right? There's no need to reload the global because it's not going to be overwritten by this pointer access. So you can just do return 30. This is essentially the transformation that it's doing, return 30, and you're still writing to the global anyway. All right. This graph format is really nice for representing data flow, right? The flow of data goes from the start to the end. That's control flow. But with pointers goes to the storing and loading, and these things happen independently of each other because they're in different regions. This is a nice way to represent storing and loading and all these things like that. And this is called a sea of nodes approach. It's a whole bunch of nodes, and they're all they all depend on each other, and that's how you represent these data flow. And then things like things like an if statement. Yeah, things like an if statement. Control gets passed here, and the parameter C if has two branches, true and false, branches to a region. And this region is connected to a fi node, true or false, and then control gets propagated to the return. Seems very intuitive because, yes, it is quite unintuitive to a normal compiler developer, right, who doesn't really work with graphs like this. They work in a statement-based, structured, static form. This is really hard for me to understand. I'm gonna say it short. I mean, I've done all these graphs, right? I've did my research. And it's really fucking hard for me to understand these transformations and optimizations just from looking at it. That's actually quite easy, right? This is just another way to represent static single assignment form. All SSA and sea of nodes and all of these things, they represent the flow of data with respect to control flow. Same thing. This is the same thing. You still got the fi nodes and everything. But it's just it's not a malleable thing to work with and understand, right? Right. I got a statement. I can't, in my brain, I just can't really think of all of these webs of nodes and all this interconnected thing is. I like to think of a top to bottom. I like to think top to bottom with my intermediate representations. But this is a nice introduction to sea of nodes. The reason why I was telling you this is, for one, I spent a lot of time on it, so I got to tell you. But the reason why I'm telling you this is because it's a nice way to represent the flow of data. And the flow of data, when they can happen simultaneously, mutually exclusive of each other. That's regions, right? I hope you understand how, if I have two parameters and they're in a different region, you can write to this one, and you can reorder them. They don't depend on each other. That is one of the best things about regions, and I think I explained it well. because you can see these two diverging paths. Anyway, no more graphs. I'm going to explain what I want to do with a compiler. This here struck a sea of nodes, and then in reality, this is just my linear thinking all the way down, just linear thinking, like, and then I eventually diverge into something quite familiar, This is called block SSA with block parameters. Let me go Swift cell. Okay. No, that's not the real Swift. Okay. What's the best way to explain it? Best way to explain it is with an example. Actually, no. Best way to explain it is with an example in cell. Let's block parameter. Block parameter. Oh, come on, you don't have here, basic blocks. Come on, what's your video? Chris Latner. Okay, best way to explain it is for me to cook up an example. Block parameters. All right, so you have a function f takes in a bool, returns an I32. F c equals if c 30 else 20. Pretty simple. All right, and inside this is an SSA form. I'm gonna do it in a static single assignment form with like phi nodes that you're used to seeing specifically in LLVM and things like that. All right, so you have an entry block. So like function f main.f, and it has a what's it called, c, which is a bool. Okay. On entry, you're gonna do if c go to and then what's it called, block. Yeah, so the control flow will split off. So block truth and block false. So true and false go to block T, else block F. Okay, and then you do is exit. So in block T, you're gonna go to exit. In block F, you're gonna go to exit. And then inside here, we do like this is just the v0 is just the normal thing, and then we do phi block T. So if it goes to block T, it's 30. If it goes to block F, it's 20. And then we just do a return v0. Make sense? I think this makes sense. So F is a bool, returns an I32. F binds on C. If C 30, else 20. And then in the function, it goes into an entry block. So this is the terminator, like the br if, branch if. If C, then go to block T, else block F. Then inside you just go to exit. And when you reach exit, you come with a phi node. So this is where these control flows they diverge, and you can this is data flow with respect to control flow. So so like if you came in from block T, you get the value 30. If you came in from block F, you get the value 20. It's a very simple explanation of phi nodes. And what you could do instead is you can use block parameters. This is something not new. The Swift language uses it, and MLIR uses it. MLIR is the successor to LLVM, which means they know what they do. They know what they're doing. They know what they're doing. And when they know, yeah, which means block parameters has a certain amount of weight to it. If LLVM, out of all things, are moving away from SSA and phis and into block parameters, you know they really mean it. Okay. Okay, and then there it is. Exit takes in a v0, which is v2. All right, these two are equivalent. They may not look equivalent, but they're essentially equivalent. So if C, then go to exit 30 with a block parameter of, with a block parameter, go to exit with a block parameter of 30. Else, go to exit with a block parameter of 20. When you get to exit, V0 will be I32, return I32. These, believe it or not, these things are equivalent. They are completely equivalent. They represent the exact same thing, except a block parameter form is just nicer to work with. They represent the same control flow, the same data flow, the same static single assignment, everything. When I saw block parameter, I was like, I didn't really think too much about it. But when I really thought, what really turned me off from using this representation with explicit phi's in my compiler is because phi's are really fucking annoying. They are so annoying to work with, because even the LLVM and MLIR developers, I mean, they talk about how they have to write specific things to skip over phi instructions. You need to make sure phi instructions stay at the top and all these things. If Chris Latner, the guy behind Mojo Swift LLVM, is saying use block expressions, use block parameters, use block parameters. I think they're a lot nicer. Anyway, I'm using them in my intermediate representation. So my current intermediate representation is an AST tree representation, but now I'm gonna make it completely an SSA with block parameters. And you may think like, isn't it harder? Really not. When you it's not that hard to go from a functional representation like this to a flattened SSA representation like this. You don't need an AST in your programming language. Okay, you don't need an AST. I don't really like ASTs. If I'm writing a programming language, I'm just gonna skip an AST. I'm gonna find a way out of it to skip it and just go straight into an abstract IR. That's what I tried to do with the HIR, high level IR. It's a tree-based representation. It's like an AST, but there's things desugared, and it doesn't really represent the syntax. All these choices of IRs. So the reason why I'm going with this is because there's no phi nodes. Phi nodes are really, really annoying. What's the best way to explain it? I mean, even here, this is one of the notes I write myself. Functional yet imperative. Let v equals loop infinitely. So v evaluates the bottom type. It'll loop forever. It'll never, you'll never produce a value of v. V will never get a value. So you could lower it to with entry. V0 is a local. Go to loop and loop and loop and loop and loop and loop. And then you can just create an exit with a v1 of no return, and it'll store it. And I mean, this is nonsensical. You'll never get here, so why even omit it? But it works great for type checking, right? Because you're storing this extra information about the state of control flow that you can type check, right? Usually this information is lost. Usually people don't include it. But I want this IR to be a jack of all trades IR, where I can do everything in it possible. Okay, there's some these are some really cool abstractions that I eventually want to do. Yeah, expanded. So this makes it really easy to do macros, because all you have to do is splice the start and end blocks. No need to wrangle with phi's. Okay, yeah, where is it? It's just some, yeah, it's just semantic stuff. There's some regions. The graph representation I've translated to a thing by thing representation. This is not going to be in the final product. I'm not going to do these kind of invalidations in the final product for a specific reason that you'll find out. Yeah, blah 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 blah. I was doing this today. I put this in announcements. Oh yeah. So what you can do with a block IR is I think I do like go to. You can have like syntax sugar that you expand. It's like instead of this well, okay, the first problem. How do you represent pattern matching in a statement by statement control flow IO? How do you represent pattern matching? Because you don't want to unwrap the pattern matching, because you need to check, is this pattern matching right according to the type? Are these I32s, right? You're gonna lose information if you unwrap it to like switch statements or too quickly. So when you get to here, what will generate in the parser is function add, takes an I32, returns takes an I32 and I32 returns an I32. The entry block has the parameters P0 and P1. And what you can do is you can use this kind of like this abstraction, this go-to pattern abstraction that will later on, after the type check, can be expanded. So go-to pattern P0, P1 to labels add 0 and add 1. And I mean, it like isn't this really intuitive? So add is a 0 0. It takes nothing. It just go to with ret 0, and then add the add branch, add the 1th index branch takes in an A and a B, and then v0 A plus B go to ret. This is a really nice way to do abstractions, because currently I'm not unwrapping the pattern. Later on, after in type checking, I'm gonna unwrap this go-to pattern into if statements, switch cases, and all these things. But you can retain this abstract information from the parser. You can retain it and then unwrap it later on. Yeah, just some local stuff. Yeah, access strategy. Yeah, optimization of closure. Let t equals 20. Let a x equals x plus t. You can move the 20 up here. Implementations of closures as well. That's great. I'm using the same go-to pattern instead of go-to closure. All right. This is just some notes. This language, same thing. I've already talked about this. All right. So what I want is optimisations of closures. So this is a constant propagation. Let t equals 20. Let c equals lambda. F goes to f plus. No. Let c equals function of f equals f plus. What am I talking about? It's a lambda that takes in an x, returns x plus t. Sorry, I was thinking of math. I was thinking like f of functions. Anyway, what you can do is move the 20 up here. Simple. I think that's pretty simple. Hard to do in an AST. Quite hard to do. Yeah. Okay. So conditional constant propagation. That's another thing that I was looking at. So let mutable g with nothing in it. If c, g equals 20. Else g equals 50. Now what I want to do is let c is a lambda. X goes to is g greater than 0 or f or x equals 0. What you can do, because when you get to here, you know g is always greater than 0, which means this evaluates to true, which means it discards the second thing, which means you can evaluate to let c equals x equals true. This is a valid optimization we can make. It's just that ASTs, you can't really do that in an AST. It's really hard. It's Socrates says the function thing is hard to do in an AST. Do you mean like lambdas, like these closures, right? Like optimizations, like constant propagation into lambdas. Do you mean that? Yeah. Okay. It's very hard to do in an AST. There's a couple of reasons why. Well, okay. An AST isn't suited for any of this. I can say it's hard however much I want. I can say it's hard however much I want, but in reality, you can do this in an AST. It's just really, really annoying. Because you don't get these. You can't do with respect to control flow, because in a using this control flow graph thing, what you can do is you know that g equals this and this, and when you get to here, you know that g would have gone through this transformation, and you know g is always greater than 0. with all of these things. It's really hard to represent control flow in an AST. AST represents a tree of expressions or a tree of statements, a tree of your syntax. It doesn't represent a tree of your control flow. So there's no way to do data flow analysis. Socrates says, I don't understand half of the stuff, just hoping to learn. Yeah, you'll eventually get it. I know I'm talking a lot of stuff. What I want to do, what I'm currently doing is I'm just spitting out all the information I have just as future reference, right? Because when I do these streams, and before I implement something big, I want people to know about what I'm implementing. That's why. Yeah. See, when you have a tree, you know that, oh, x equals this tree of values, right? But inside that tree of values, you can have like an if statement in there. Like, oh no, control flow diverges. You can't be sure where a value is. See, an AST only tracks a tree of your syntax. It doesn't track control flow. So it can't reason about the state of variables after certain like if statements or loops. This is the great thing about control flow graphs, a CFG, or all these representations. A great thing is the ability to reason about control flow, and that is why I want to be able to, superpowered constant propagation. Yes, so you can make this transformation. This is a legal transformation. C equals x goes to true, because G is always greater than 0 when it gets to here. But if you did G equals this is now not a valid transformation. You don't know, this will either be true or false. But if they're both above 0, because you can walk back into different control flow and understand what the value equals. All right. Data flow checks. This is important too. This is another language-specific optimization. It's a functional language. That means it has to have algebraic data types, which means you have like your optionals, right? An optional to an I32. It can either hold nothing or hold an I32. Now, you can do... So G is a optional I32 equals something, right? It's just something. And then when you do a match on it, when you match on X, it goes to nothing, and if you match on none, it calls this big hefty function, which just kills the program. It kills the program. This function evaluates to the exclamation mark, which means no return, which means when you call this function, you will never, control flow will never go back, right? And you can use this reasoning that if you get to here, you must have taken this branch. So if you get to here, you must have taken this branch, and if you ever take this branch, you would never get here. So what you can do is, let C equals I32 equals G postfix question mark. And that's unwrapping. You can unwrap safely. This is data flow things. This is really hard to do in an AST. The V compiler does it in an AST. I've read the V compiler in doing it with an AST. It's really hard. Well, it's only hard when you have okay, well, there's a difference between hard and you can't solve it. You can't solve it when there's unstructured control flow. You can't solve it when there's unstructured control flow with gotos. But if there's just simple if statements and loops, you can solve it. You can solve it. It's just really annoying. It's just really annoying. So why can't I just do all of this at once? You don't need to write all of these specific checks and duplicated code. All of this, constant propagation, conditional constant propagation, data flow, all of this is basically the same algorithm. It's basically the same algorithm. Yeah, and another thing is region checks. F takes in 2 pointer to I32s. Let A equals 10. You're calling F with the address of A and the address of A. This is an error, because by default parameters are supposed to be in different regions. So this will raise an error. But if you have this, let B equals 10, and this, no error at all. Alright, simple. Very super simple. Hard to do in an AST though, really hard to do. Okay, I keep saying really hard. Um, it's akin to, I don't fucking know, doing glass blowing with a hammer. It's the it's the wrong tool for the it's the wrong tool for the it's the wrong tool for the job, right? An AST is nice for type checking, but you won't get any analysis out of it. You won't get any analysis out of it. You know, all of these things are solved with moving away from an AST. So, and I have a ton of other things coming up with, you know. Well, let's just take a look at the compiler currently. Over the, and what time is it right now? 51 minutes. Wow, I talked for an hour and I haven't even hit the compiler yet. Okay, GCC, and we're running it. That's not right. What node is that? Let me just fix this real quick. Node 31. Tuple field. Supposed to be here. Alright, run it. Oh, what? Oh. Okay. 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 Main is a function that takes an empty tuple and goes to do. Let v equals a tuple of i32, a boolean, and i32. Let k equals v.1. And this is the intermediate representation. It's tree based. You can see though, it's not an AST. AST stands for abstract syntax tree. It's not an AST because it doesn't represent the syntax at all. What I like to call it is the HIR. This is the high level IR. It's tree based. It's like an AST, but it doesn't represent the syntax at all. So this function main equals do let v equals k equals v.1, right? This essentially goes into a let. Main equals lambda goes to match. The first arm of the match is the empty tuple. That's what you're matching here. Goes into a do block. Let v equals a tuple of i32 bool i32 equals 1 false 3. K is a bool equals v.1 is just the identifier name because it's supposed to be prefixed with that. But the .1 is a tuple access. So you're accessing the tuple. You're accessing the tuple member at index 1. So that's false, which means k is a bool. And this is the tree representation of the syntax. It goes from the lowest to highest of just the syntax. And what I do for printing it is in the HIR. What I do for printing it is simply just a recursive function. So you just print and recurse, print, recurse. So node assignment, you print the left hand side, you print this, you print the right hand side. This is a tree. That's a tree. And that's my old IR. Old IR. But now it's time to move. It's time to move to something completely new. Before I do that though, I'm gonna get some water. So, sorry guys. I'm dying here. My throat's dying. I'll be right back. It'll be super quick. Hello? I'm sure you can hear me. Alright, I'm back. Okay, time to do the hard stuff. This is the hard stuff. To do. Why do we even have these stupid little ops? Why can't we just de-sugar? Okay, we're gonna do this. We're gonna commit just this, the old stuff. Minor bug fix for tuple. Okay, this is a minor bug fix. I'm not adding the current stream tag because this is this work I did a while ago. Okay, time to rip everything out. I'm gonna rip the whole fucking thing out. So, first we'll start with how is this IR represented? So, the one at the top of the hierarchy is functions. So function is at the top of the hierarchy. A function contains a list of blocks. And those blocks can take arguments, but the function just accepts a list of blocks. It contains a list of blocks. Those blocks have a list of instructions. And inside those instructions can reference these mini SSA values, those registers, those register-like thingies, and we have locals. So yeah, so we have functions. Those functions contain basic blocks. The basic blocks contain instructions. Instructions can reference places. SSA values. Yeah. And what I mean by SSA values, I mean entry. Entry v0 equals 0, v1 equals 1, v2 equals v0 plus v1. Yeah, so we're adding v0, v1 goes to v2. That's it. Yeah, so can reference places, registers, and SSA values. That's what these instructions can reference. So this whole thing is an instruction right here. v0 goes to v1. All right, so functions contain a list of basic blocks. All of these are basic blocks here. All right. I think this is where to start. So I can start by defining a function. So all of these node stuff, goodbye. But what I'm keeping is HIR pattern. I'm keeping this. But what's going is a lot of stuff. So we'll start at the very bottom. Struct. I'm going to start by type. Type def struct. What are we going to name it? What's the IR name I'm going to name it? I think I'm still going to name it LIR. Look at name LIR. Hold on, let me check if my stream's even on. Pretty sure it is. Hold on. Yeah, it's on. Okay. Nothing to worry about. Okay. Type def struct. I'm gonna just name it LIR, like a lowered IR or a abstract IR. AIR. I'm saving AIR for assembly IR. It has to have a cool name. That's this important part. I'll just write LIR. LIR proc or func? I think proc. Procedure. Like the word proc. Alright. Struct LIR proc T. So it contains a list of basic blocks. So we're going to do type def block T. struct. Yeah, this is the block. So, yep, this is the blocks. And then we'll do type def. All the instructions. Yep, and blocks have a list of instructions. Good, and they also have a list of parameters. I don't know what I'm gonna name those though. A value probably is one of them. Value. Value t and then value ref. R value seems weird because R value is already a known concept. It's not R ref to value because that's the naming convention I use in here. Like R mod index reference to mod. Alright, block T has a R value T args. Blocks have arguments. And blocks also have a terminator. So, to help you explain, all basic blocks must end with a terminator, something terminated. So, valid examples of a terminator is a goto to a new block. This is a valid basic block now, because entry has all these instructions, and it has a valid terminator at the end, so it goes to a new block. Another valid terminator is a return. Entry, this basic block always has a terminator, and that is return. Yeah, so basic blocks need a list of instructions, list of arguments, and a terminator. Yeah. So type def struct. There's like term is fine. Struct lir terminator. Term. Okay. Okay. So we have a list of instructions, list of arguments, a terminator, and a list of blocks. And what the proc has to do is store a list of these values. When I mean values, I mean these things. V0s, you can reference them. These can have attached debug info, which means they need to have to be stored separately. So, lir value t values. Just an array of values. And then r value t is the arguments and the instructions. Instructions have like a target, don't they? Target. And then we'll also do a define. Yep. None. Yeah, I reserve all the bits for invalid. Because when we compile a program that takes us long, it'll never reach that limit. Okay, instructions have a target to write the value, and then they have tons of things they can do. They can do like addition. Simplest thing for me to do now is terminator. So enum kind. We can do lir term goto, lir term return. Do ret. I like the word ret. So, and then you'd probably want to do union. Yep, thank you. D go to lir block T is a target. What I'd want to do is a reference to a block T, which is a I32. Right? Right? Yeah. lir block T. So the target is just an index, and the ret is just a value. Simple. This is really simple so far. Okay. And the instructions. So right now we have a target, and then we have a enumeration. So enum, and these, I want these to be U8. What's this? Expected expression. Oh, whatever. These can dictate themselves. Alright, kind. lir term. Oh, not term. lir inst. It's integer literal. So every instruction, no, every value has a type. So inst integer literal is just a string literal, but it has an underlying type, so it'll be cast into its literal. Okay, kind. And then let's do a big union for me. All right, d integer literal. I stat lit. This is very similar to here. Very similar to all these nodes. But I think what we can do is cut down on the amount of nodes we have by half, because I think most of these are some of these are like control flow. We can even remove like node voiding and things like that. There's things that depend on control flow. We can cut all of this by half. All of the old nodes. Yeah. All right. Inst integer literal. I'm not sure. We're like lir integer literal. This is too long. Is it just node? Yeah. Okay. Fine. Inst integer literal. Yeah. And then we'll do term go to term ret. Integer literal, and then what do you want to add? You want to add like infix. We're gonna make these explicit. Instead of an infix, they're just gonna be add sub mul div. Okay. And then we'll do a struct the infix LHS and RHS. Yep, and the target should evaluate to a type, right? Should. All instructions should have a type on them. No, they shouldn't. Okay. LHS, RHS, dinfix. Sounds good. Sounds good for now. LIR value T. Alright. Struct values. The value T one of these things. So v0 equals 20. Those are the values. So it'll have a current index, it'll have a was lir r value T. There is no use defs in this. What's it called? It's called no, index. Yeah, index itself. All right, has an index to self, and what else does it keep? It keeps a type. lock t. More debug info. Yeah, so the proc. Okay, so let me recap. Proc has a list of blocks and a list of values. These blocks contain instructions and arguments, which is a reference to a value, and it contains a terminator. Inside these instructions, we have a target, so this is an assignment, and then we have all of these. Okay, so what we need is a we need an interface, so we'll do lira.c. And what I want to implement specifically is the creation of these things. The lir will be a, so include currently what I want the API will be so I want to do create a new proc. API design in compilers is really hard because I want to be able to create okay, lir proc. It'll return a lir value. It won't return a reference because this is an unstable pointer. But it will return the index, so value new. And it takes in a proc. Lir proc t pointer proc value new. And what I want to do is new none. Okay, yeah. So lir r value t lir block arg. I want to take in a block, and a value. A block should also have itself. Index self. So this is self-referential. So a lir block arg is takes on a block, and a value, and adds a new argument to that block. Okay. Void lir terminator. I want to assign a new terminator. I want to be able to create new values. So this is with this. Create new blocks. Block 0 is always entry. Okay, so let's go implement this. Pretty sure ChatGPT can do it for me. Not ChatGPT, Copilot. I mean, just fill them in. That is not right. That is not right at all. Okay, lir value new. So what we need is include stb ds. Okay, so in your proc we have values. So alright, this is the IDX. Value dot. dot index. Yeah, dot index equals IDX. We're setting it, and then we just put it in. All right, return IDX. Pretty simple. Even simpler. What do you have for time? An hour 17. I think I can demo one of the things I'm going to do in the parser as well. Yeah. So block argument. I'm going to add a new argument to a block. So takes the address of a proc blocks b. Get the length of the args. Value.index is... That's not right. It's value new, and then insert. Return our value. And what's the last one? Assign terminator. Simple. The simplest thing in the world. What we want to do is create instructions, so. Do we ever have an rinst? No, we can only iterate them. So we're creating an rinst type. Block. Inst new. All right. Takes in a proc, block, and an inst. Returns an rinst. Good. And we can just implement that. Does inst have an index? It doesn't even have a self. It should have a self. I don't feel the need to have one. No need for. Okay. Oh, it's returning an rinst. What we want to do is add like a builder. Return IDX. Well, what we want to do is add like a sort of builder thing. So it returns an rinst. Rinst new. So new is the general thing. But what we're going to do is create a new instruction with a inst value. So takes in a procedure, a block, current instruction, and a value, right? You'll return a Yeah, type T. Okay. Returns the lir r value. Okay, this is a handful. It's a big one. All it does is simplifies the creation of something like this. Let's say you don't really care about the type of v2, but you just want to what's the word? Yeah, you just want to create everything in one go. You want to create v2 while passing in this. So it takes on a proc block, the type of v2, the location of v2 if it has one, and the instruction. So this is the instruction, and then it returns the value. It's like the builder. Okay, well, I don't understand the need for that. Okay, and what else? Return. Okay, inst.target equals our value. And then we add a new instruction. We ignore it. It's only our value. Inst builder. Okay. Oh, so 1 hour 22. I think what we can get done is so this is a nice sketch out so far. So we sketched out all of this. I need to implement the parser, and there's a lot. There's a lot in the parser right now. There's just so much. Oh man, this is something I'm gonna have to do off stream. But what I can do on stream is probably nothing. Probably nothing. I don't know. Okay. I'm quite tired. I feel like I might stop the stream, but not before talking about what I want, where I want to take the language. Um so this thing, the parser, this is so much work. This is like an unbelievable amount of work. Well, not unbelievable, but too much to do on stream. I do not want to do this on stream. I'm sorry, I'm not going to do it on stream. But there's specific things that I do want to show, specifically how it lowers. Next stream, if I have the parser done, which it's possible. It's possible I have the parser done. But when we get there next stream, I'll show you how the parser works. It'll work using a value stack. This is how the tiny C compiler does it as well. It's a very novel technique. I use it in VUA as well. One of the old things. It's very nice. It's a way to do expression parsing, but you keep context and everything. What you should look up the tiny C compiler. TCC. Zaka6 says, how many compilers have you made before, or it's first? So I'll get back to this. So YouTube videos. Nice, thanks. So how many compilers I've made? I've only made one compiler so far. Well, I've only made one programming language so far. I made not a dozen compilers, but I made a couple, right? 3 compilers. So the most like production compiler or something also seems the VOD repo is private. It is private. I'll unprivate it right now. And it's such old code. Sorry, I'll get back to your question. Let me just do this real quick. How do you do it? Forgot. Visibility. Public. That is so bright. Okay, let me just move this over here. Hold on. GitHub. It's TOTP stuff. All right. I think it did it for me. I think you should be able to. You should be able to see it. Fuck. Public. ePublic. Yeah, you're probably public. Okay. Yeah. How many compilers have you made before? Or is this the first time? This is not the first time. I was very interested in compilers a very long time ago. My first programming language that I ever made was Stas. It's pinned at the top. It's public archive. Stack-based compiled systems programming language. In the loosest terms in the whole world, this is what it is. A stack-based compiled systems programming language. It's very loose. Very loose. I'll tell you why it's very loose. It's because it's the most unsafe program. It's so unsafe. This programming language is akin to a like a. It's like a. What's the best way to explain it? It's like a high level. It's like a high level. It's like. You know how people say C is a language that translates very well to assembly. You can look at the C code and you can tell what assembly it generates. With stars, I take that to a whole another level. The whole language works on a stack, right? So let's say I put 15 on the stack. This is a 64-bit value on the stack. More values and more values and more values. You do a plus operator. It pops off 2 values on the stack. It adds them together, adds a new value on the stack. This is how it works. Now, these values are 64-bit pointers with no type. Not 64 pointers, 64-bit integers with no type. There's no types in this programming language. There's the only types is like an assertion where how many values you're passing between things. This is wildly unsafe. I can't believe this is like a dialect of assembly, basically. This is a dialect of assembly. I can't believe I wrote a complete compiler on this like wildly unsafe language. It is like it's so unsafe. So this is my first compiler, but it's a great one. It's one of my it's really it's a nice compiler because it does optimization. So it generates optimized x86 assembly, cogen optimization, parser, checkered, sports, freestanding Linux and freestanding FreeBSD. It does peephole optimizations, tail cool optimizations, constant propagation, constant evaluation. It has support for const functions. Anyway, this is a fully fledged programming language. You can go use it. I wouldn't suggest you use it, but this is my first programming language. I've made a couple compilers after that. I worked on the V compiler for a while. I'm a V developer. I'm part of the V. Oh fuck! I'm part of the V organization. So you'll see my name dotted around in a couple places. Oh my god, yeah. But I worked on the V compiler. So I worked on stars. I worked on the V compiler. I worked on a couple compilers in my spare time. But during that time, I was making notes. I was writing notes upon notes upon notes about how I want to build my own language, right? And this is that language. So this is new lang. This is a folder called new lang. You see all of these notes. These are big notes, and this is new lang 2. These are more structured notes, but this is my compiler that I want to end up on, right? This is hopefully my last compiler. Well, not my last compiler, but this is going to be a fully fledged programming language that I really want people to use, right? I want to go out and I want people to use it, which is why I'm making it the best it can be. Yeah, so I made a couple programming languages before. I have a decent amount of experience. I like to say I'm pretty experienced. Because I've worked on big compilers and little compilers and my compilers. Yeah. But to end the stream, I think I'll talk about I don't think there's much to talk about really. How I turn closures into when I lower them. Let's say this is the entry block. T equals 20. I'm going to do a go-to closure. This is another terminator. It'll jump here, and then the closure will be available. So go-to closure. Closure takes in a T. So this is the environment. It'll go to closure, and then here you can use the closure. It seems very weird, but after the type checking, all of this will be like desugared and stuff. This is a minimal way to keep information instead of like desugaring it immediately, because you need type information to solve these things. Specifically, yeah, so I talk about here, implement patterns by using a go-to pattern, which gets converted into ifs and switch statements and things like that, right? But right now, from the parser, it gets generated into a go-to pattern and goes into these things. So this is a really nice way to model these things. Yeah. And then here you say let a tuple of a to a tuple of b, c equals value, we'll force a pattern match here. So entry equals v equals, I don't know, and then we'll do like go to let pattern, yeah, go to let pattern, continue, and then v0. Then I will unpack the a, b, and c. So this is just a nice these are basically no-ops in the language, but these are nice hints to let the checker know that these are a let expression, or this is a match, because other than that it would have been erased by the immediate desugaring. There's things that we can't desugar without types, so we need to get types in here. So this stream, it wasn't particularly productive, this stream. I just want to go over everything. The reason why I stream is because I open up the stream and the most important thing is for me to tell everyone what I'm going to do next and my current implementations. It's a little less about code writing. It's more about theory. Zaka says, I'm currently stuck at constant resolution. I can create a dependency tree, but due to having constant procedures, it would be slow to resolve this from ASTs. And constants appear in array types, which blocks the ability to do full type check. Consider making full untyped IR like in Zig. I'll see, let me try and visualize your problem. So you have a const A equals 20, and then let's say a let B equals, B is an array of I32, let's do like 2 equals 1, 2. This is what you're trying to do, I'm pretty sure is what you're trying to say. And you're saying, I'm currently stuck at constant resolution. I can create a dependent, so this is like you mean like a dependency tree on what closures depend on each other. Okay, that makes sense. But due to having constant procedures, it would be slow to resolve this from the AST. Const procedures, global constants, and size of t. Oh man, I'm gonna want to add this on my own language. So what you just explained is a very hard thing. What programming languages do is constants. So I'm going to assume that constants can only be declared at the. Actually, no. When constants are declared at the top level, they can be in any order. Is that what you're talking about? Constants at the top level, they can be at any in any order, right? There's like not hoisting. It's top level constants. If a constant was inside a function, that would be very easy to resolve. But okay, when they're at top levels, I'll explain what the Haskell compiler does. Haskell uses a HM type inference Hindley-Milner. So it has to go linearly from top to bottom, and when you reach an identifier, it has to be already resolved. Oh god. So what the Haskell compiler does is all the top level declarations, it runs a pass. It goes inside the top level declarations. Are you referencing something that's ahead, right? So all it does is you have a list of these top level constants, and after the pass that Haskell runs, it sorts them. So let's say this accesses like something down here. It'll sort them. This will go up to the top. So this will get type checked and then this. And then it goes a linear scan from top to bottom. I think that's your solution. A linear scan from top to bottom. However, there's going to be things in cross-mod. I think you'll probably, an issue was cross-module. Constants from cross-module. I think that's one of the I think that's a thing that you're probably adding as well, constants cross module. So what you'll need to do then is ensure that modules don't have cyclical dependencies, and then you have to sort your modules. That means when you're parsing what are you saying? I did make a dependency define cycles and resolved everything nicely before. And did you get rid of it? But now I want constant procedures, which is bad to do from the AST. Constant procedures. So languages like Rust and Zig, they use a separate intermediate representation. Rust is MIR, mid-level IR. Zig is, I think it's ZIR, ZigIR, untyped ZigIR. Meaning that the interpreter would be slow. Well, okay. I'm pretty sure the ZIR is a tree walk interpreter. I'm pretty sure. Oh god, I don't want to Zig interpreter. Is it a tree walk interpreter? Comp time interpreter. Please don't blast me in the face with some brightness. Please don't. Please don't do it. Okay, good. Let me find out. Is this a tree walk? Interpret result. Hunt it down. Wow, these are some funny names. Now, is this a tree walk? Sorry, I just want to solve this question. Huh. Okay. Now you're saying, yeah. So this is what I suspected. The Zig intermediate the Zig comp time is basically AST. You're basically going tree all the way down. So you say the interpreter would be slow, but in reality, it's really nothing. It's really nothing. If Zig does a recursive tree walk interpreter, and it's fast enough, I think you're fine. What Rust does though is it converts your AST, so it has a typed AST, into a MIR, mid-level IR, and that is statement-based. That is basically what I am doing with this IR, with our statement control flow blocks, and then they do constant propagation on that. Not constant propagation, constant evaluation on that. I think you already have all the legwork for constant. You already have all the legwork for like dependency trees and cycles and everything's so nice. But I don't see the reason why not to do a tree walk interpreter with the AST. I don't think that's such a bad idea. Now you have two solutions. That's your first solution. Your first solution is to do a tree walk AST interpreter. That's what Zig does. It's fast enough. You don't have to worry. It's pretty fast. You don't have to worry. You already have all the legwork. You've done the hard part. The easy part is interpretation. So that's your first solution. Your first solution is to do a tree walk. Your second solution, ditch the AST entirely and do what I'm doing. So what I'm doing is, and I talked for ages. I don't know what time you got in this stream, but what I'm doing is, you know how Rust goes from an AST to a MIR, like a mid-level IR? I just ditch the AST and just go straight to the mid-level IR. So it's already in a control flow statement-based, comp time ready thing, right? Yeah, so AST, HIR, yeah, typed HIR and MIR. So that's all the ways the Rust goes. Yeah, many stages. Yeah, so what I do is I just skip straight to MIR. So you got two solutions. Tree walk interpreter. I say that's your best bet, right? Because you've already done all the hard parts. Or the second part, you can just skip the AST entirely. Right. Skip the AST entirely. You know, if I was writing a Zig compiler, I wonder how it would work if I could just skip the AST entirely and represent the entire Zig language as this like a state machine or something. I don't know. It's just these random thoughts. But I think it's fine to do a tree walk interpreter on the AST. I don't think it's a big deal. I don't think it's a big deal. Zig does it. If Zig does it, you can do it too. I think that's where I want to end the stream. Yeah, if you have any more questions, you can ask away. But I think I'll just take a look here, and then if no one has any questions, I think I'll just end it. Good stream though. Good stream. Yeah. The real hard part is the dependency tree and cycles. So you've already done the hard part. Just you can reward yourself with a tree walk interpreter. You say it just feels wrong to do everything on AST and inject extra info. I'm pretty sure a tree walk AST doesn't. A tree walk interpreter just needs to store everything as like values. Like I don't think you need to write extra info in the AST. I'm pretty sure. No, I am sure. You don't need to write extra info in the AST. I think you can just return a value and then just like a boxed value, or not a box, like a struct, a tagged union or something. Yeah, it's a yeah. Socrates says, thanks again, man. I definitely make progress on the Lua interpreter. Yeah. I wish you luck. Zaka says, I mean, the semantic checking needs to inject extra info in the AST when the AST becomes not as pure. Oh, semantic checking. Oh, I just assume that AST gets extra stuff put in there anyway. I treat ASTs like intermediate representations anyway. If I'm writing a compiler with an AST, I just shove the types in there. It may not be an AST anymore, but who cares? Yeah, it's not a concern. You know, if I were in your position, what I don't like doing is I'm really stingy with the amount of IRs, right? When I look at Zig, like when I look at Rust, it goes from like AST to type to AST, which is fine. I consider those the same thing. But then it goes to mid-level IR, and then to LLVM, and then out, right? Why can't you just go into mid-level IR and then have all the dataflow optimizations and everything all the time? And you say, I basically resolve names to IDs, which is fine to have inside the AST, and this would allow you to do the imtab. Yeah, no, what and I talked about this inside the server, Discord server where I announced my streams. I was talking to someone about proc ID, struct ID. What you can do is every single variable inside of a function, not at the top level, every single variable inside a function, you don't need to store scopes for. You can statically resolve them while parsing. And that's what I do for this language. I statically resolve as much as I can during the parsing step, and then anything left over is a global variable, right? Is either a global variable, or if it's not found, it's a hard error. So, I mean, I'm going to be storing that information in the AST anyway. I don't even think I would store a string representation of the name. I just store a name, like a reference to a local. Yeah, I never really do ASTs like ASTs. A good way to explain that would be here. Let main.0. This whole thing is a local thing, so it's a main dot, and that .0 is its index into the locals. So it'll be a main. The name is main, but reality it's at index 0, and this is just this is my AST, but not really an AST. So it's just let main equals this match on variable 0, and this is the third index. Yeah, the names don't matter. You can remove the names and just leave the indexes. Yeah, so let v, let k, bool, extraction, break, nothing. Yeah, I would just be storing that information in the AST anyway, and not treat it like a syntax tree. Yeah. Yeah. That's I think that's all I have to say. I think that's it. If it's a good stream though. I answered a lot of questions. I really enjoy answering questions, by the way. I have a lot to say. The good stream. Thanks guys for coming. But I think I'll end it now. I think I'll end it now. All right. Bye. Thanks, guys. Thanks for coming. Goodbye. Thanks.